All right, guys, we are looking at 12.4 now. Okay, we're still factoring, but we're going to be looking at some special cases here that we're factoring. All right, so that's what our learning targets are. I can factor perfect square polynomials. I can factor using the difference of two squares rule. And I can use the structure of an expression to identify ways to rewrite it. All right, so we're going to move on from that. Let's review here. All right, let's factor some of those things we've already done. Okay. Now, we know that I have to find the factors of this last number. All right, factors of 25 are 1 and 25, and 5 and 5. That's it. All right, now I look at my rules. They're the same sign, but they are both negative. And I'm looking for the ones that add up to my middle term. And in this case, pretty obvious, it's going to be -5 and -5. If I do my box, I'd have x squared, 25, -5x, and -5x. Find my greatest common factors. For this row, it would be x. It's going to be 5, and it's touching a negative box. Do this way, it's going to be x again. It'd be 5, and I'm touching a negative box. So my answer will be x minus 5 and x minus 5. All right. What you need to notice here, isn't that the same? If I wrote this right here, if I were to write is that the same exact thing? And I want you to think about that. All right. And you should be yelling at me right now saying, yeah, that's the same exact thing, right? If I were to write that out. All right, so on this one over here, I'd find the factors of 9. They're 1 and 9, 3 and 3. My rule tells me they're the same sign, and they are both positive. Draw my box. I would have x squared, 9, 3x, and 3x. Find my greatest common factors. The greatest common factors of x squared and 3x is going to be x. Greatest common factor of 3 and 9 is 3. It's positive. I think you guys are probably to the point now where you can do that pretty well. All right, and if I were to write that out, it would be x plus 3, x plus 3, which is the same thing as x plus 3 squared. All right, so let's move on. What's the pattern between the middle and the last terms of the trinomials? So if we look back at that, we knew they were the same sign for both of these, right? But when I look down here, okay, whatever that sign was is whatever these signs were, right? Whatever that first sign was the sign that I had even here. Right, there's your pattern that you should have seen. All right, and a perfect square trinomial is one just like what we just did, okay? Those are perfect square trinomials. All right, so if you were to do one of those and you noticed that, whoa, these are the same exact thing, then that's a perfect square. Now, notice how here as well, it has to be the same exact sign for them to be able to be that way. All right, so if I went back to one of these, if for some reason down here on the x minus 5, this happened to be a plus instead of a minus, I cannot write it that way, all right, because it's not the same term. It has to be the same exact term in order to do that. All right, let's look at this one. Factors of 16 are 1 and 16, 2 and 8, 4 and 4. Same sign, and they're both positive. I can draw my box. It's going to be x squared, 16, 4x, and 4x. Greatest common factors. I'm going to start moving through this greatest common factor stuff pretty quickly because I think you know our pattern here. Okay, I'd have x and 4, x and 4. That's x plus 4 times x plus 4. All right, and I want you to do b on your own, which we knew this would be x plus 4 squared. I want you to do b on your own, and I want you to pause. Okay? I want you to pause the video, and I want you to do this part right here on your own. Okay? So pause it, and I will have an answer for you after you have paused. Okay? So hopefully you paused right there. Your answer, once you worked that out, would have been x minus 8 times x minus 8, which is x minus 8 squared. All right, let's move on. Now, what's a little something different here? Right? We don't just have x squared. We have ax squared. We have a number in front of that first term. And we know to do that, we have to multiply the first and the last term, which in this one is going to be 36. The factors of 36 are it's actually 36x squared. So the factors of 36x squared are going to be x and 36x, 2x and 18x, so on and so forth, 6x and 6x. I know it's 3 and 12 in there as well, but I don't really have the room. All right, same sign. They're both positive. Right there, the one that would add up to that middle term is going to be 6x and 6x. Draw my box. All right, so I would have 9x squared, 4, 6x, and 6x. Start finding my greatest common factors. For this one, it's going to be 3x. For this one will be 2. And it's positive. I go across my rows. It's going to be 3x and 2. So my answer here is 3x plus 2 squared. All right. I'm going to skip B there. Okay, it's the same concept, but we will look at C. No, we're not even, guys, we're not even going to look at C. Okay. You have nothing like that. So we're not going to sit here and spend time on it, but would I do anything differently? No. I would multiply x to the 6th and 400y squared, which would give me 400x to the 6th y squared, and I'd find the factors of that. Okay, don't let that be too intimidating. But just for the purpose of time, example A is pretty much all you need there in the sense of understanding how to do these. Okay, so now we're going to talk about binomial conjugates. All right, and as a review, it's two identical terms with the opposite middle sign, which we will see here in just a second. Notice here how these signs are different. When you do these, that middle term will be canceled. All right, so let's look at this. Remember, in Unit 11, how we could distribute, right? I'd have x squared minus 9x plus 9x minus 81. When I combine my like terms, negative 9x plus 9x cancels. So really, all I'm left with is x squared minus 81. All right. That middle term is gone, right? In the sense of if I have x squared plus bx plus c, this part right here is non-existent. It's gone. Ends up canceling. Because these are the same exact thing, but my signs here are opposite, which causes those to cancel. All right, so let's factor this one. I'm looking for the factors of 81, and now notice. So when we have something like this, this term tells me whether they're the same or different. This term tells me one of the larger factor. Now, don't freak out about this because there's no middle term, right? This is gone. So really, we know they're going to be different. If you've noticed, all these are negative. They're all going to be different signs. You're looking for the factors of this last number here that add to 0. So let's find the factors of 81. 1 and 81, so on and so forth. 9 and 9. They're different signs, okay? It doesn't necessarily matter which one is which, but they're different signs. And you're looking for the ones that add up to 0. Well, in this one, it's this right here, right? So really, my answer here is as simple as x plus 9 and x minus 9. There's my answer. Now, I'm going to show you a shortcut on example B. All right, this is a little rule that you can use for these questions like this, okay? All I need to do is I can take the square root of each of these numbers, right? Square root of x squared is x. Square root of 49 is 7. Remember, and you're just going to have one that's positive and one that's negative. It's that simple. Okay, these truly are that easy. Okay, where I can just say, all right, take the square root and the square root. I know I'm going to have one that's positive and one that's negative. Square root of 25x squared is 5x. Square root of 144 is 12. Okay? Sorry about that right there. That's all there is to that. All right, so don't let those freak you out. Find the square root of both terms, and make sure you just have different signs. Okay, probably the easiest ones if you just use that rule right there. All right, now remember the greatest common factor. What's the greatest common factor of 6 and 18? Well, let's list the factors of 6. 1 and 6. 2 and 3. Factors of 18 are 1 and 18. 2 and 9. 3 and 6. The greatest common factor of this one is going to be 6. Right? Now, with the variables we talked about, it's the one with the lowest exponent. All right. Now, when you look at one like this, you sit here and you're like, that's crazy. I don't know how to do that. Well, see if you can take out a greatest common factor. Okay? And you can turn this into one that's easier to do. Is 6 a factor of 486? See if I can take out 6 there. And just do 486 divided by 6, and it is. Okay, so I can divide all of these, or both these terms, by 6. And when I do, I'm going to end up with x squared minus 81. Now, remember, I can just take the square root of both of these, and I'd have 6 And remember, you're going to have a plus and a negative, right? Square root of x squared is x. Square root of 81 is 9. And I just did that one. Okay, that's all there is to that one. Same thing here. I can take out 10, and I'll have 10 with a plus and one with a minus. I'm going to change my color. And that would leave me with x squared minus 4. Take the square root of x squared and the square root of 4. I'll have x plus 2, x minus 2. And there's your answer to that one. Now this next one, I'm looking for my greatest common factor of the two. And in this case, it's 4. All right, no, I'm sorry. It's not 4, it's 2. I was thinking ahead. That's going to leave me with 2, 4x squared minus 25. I can take the square root of both these terms, which is going to give me, remember I have one that's plus, or one that's addition and one that's subtraction. This one would be 2x. And the square root of 25 is 5. And there's that one. All right, that's all we have for this video. I know we kind of crammed some things in there, but this is one of those things when the light clicks, it clicks, right? And you don't have to use the rules. You can work all of these out. Okay, we give you the rules because they make it easier, right? They're not meant for it to be harder. If it's harder for you, do not use them. And once again, if you all need anything or you have any questions or your family has any needs during this time, please let us know. And I hope you